Greetings, welcome to all of you. So, if you are someone who has just started with the part 2 of Convolutional Neural Network, I will request you to please complete the part 1. The link of it is given in the comment section or the description section of the same video, because this is a logical extension of our part 1 video. So those who are following this series from part 1, just a quick recap. So the problem statement which we had is identifying or classifying an input picture into either as a zebra or a giraffe or an elephant. So that is the problem statement which we took in part 1. If you remember, we took an elephant, we started putting together its attributes, and then we went through a series of steps, filtering, normalization, pooling, and then finally when we concluded that video, we arrived at a compressed grid for each of the features. So this is where we concluded the phase 1 of our session. So in phase 2, we will continue from the same point which we completed the earlier phase. So the problem statement still remains. So you have a vector and I still want to identify it as one of these animals. And if you are seeing that, how did I get this vector? I just linearly arranged the same numbers which I got from my previous iteration. So I have a set of inputs. Now I want to identify to which particular category it belongs to. And how I'm going to do it, I have a black box in between. I'm going to train this black box so that it takes this input and helps me to classify it as one of the outputs. In simple terms, this input is nothing but the features. So the features are being compressed as a vector. So I have a leg, I have a tusk, I have a head. Now I need to identify the animal. From a human perspective, I can easily say that all this belongs to an elephant. And similarly, if I'm given a feature of a long neck and a green skin, yeah, I know that it is giraffe. If it is going to be a striped skin and I don't have a long neck and neither a tusk, yeah, it's case of a zebra. Now, how do we make the machines to understand this? That is going to be our next challenge. So I'm going to take you through a theory and then allow you to work through an interactive neural network model so that you get a hang of it by yourself. Okay. So the very first thing what we do is, so we have an input layer and we know that there is an output layer. So we are going to form a set of hidden layers and help the inputs to travel through a certain path to converge at a definite output. So if that sounds little complex to you, let's go back to a very, very familiar example. Assume that you are in a new town and you need to locate your office, you need to locate your favorite restaurant, or you need to locate your hospital nearby and probably a grocery store. So you hit on a highway, you see that there are multiple exits and there are multiple junctions. So either through your help of your maps, you navigate the lane and finally arrive at the destination. Couple of times you will do it very cautiously, not to miss out on an exit or not to take a different turn in a roundabout. But after few iterations, you get so comfortable with it that you start playing your music, you start talking to your friends and still maintain the right path in reaching your destination. Very similar to it, we form a set of hidden layers and train so that we know the input layers are converging to the right output, because in the training phase we know the outputs. So if it is not hitting the right output, we keep changing the patterns until it reaches the right output. So what we do is we bring out a set of neurons in each layer and then connect our input to the first hidden layer through a weight. Now if you are going to ask me from where did this weight come in and what is this number, for the starters or to the beginners, I will say this will be, you start with a random set of numbers to your weights and then allow it to propagate to see for a given set of input where does it converge, and then you keep adjusting your weights iteratively until it converges all to a right output. And you can have multiple hidden layers, more and more, so that it forms multiple paths and you will be sure of getting to your output, right? Looks to be easy but not actually. The reason is, let me take you through a example. So assume for this set of example and for a given set of weight which I have assumed, if this is the output level which I get, where it says that with 56% confidence I am saying it is a giraffe, 10% confidence it's saying it's a zebra, and the 34% is elephant. Clearly we know that this neural network is not working because we know that this is elephant. But here for the given set of weights, it says it is 56%, it is giraffe. So what we do is we go ahead and change the weight. Now, logical question to ask is, how do we change the weight? Should we increase it or decrease it? We don't know. So what we do is, we follow an approach called as gradient descent. So what is gradient descent is, for this curve, we know that this is a point x2 is the zero gradient, or in other words, it is zero slope. So if you are going to take a derivative of this curve at this very point, the slope will be zero. At all the other points, there will be a value. So by changing my weight, is my error going to decrease or increase? If it is going to increase, that means that I need to travel in the opposite direction. If I am changing my weight and my error is decreasing, then I am in the right direction. And I need to continue to travel until a point wherein I reach a zero gradient, whereas the error doesn't change, and probably after a point the error changes in the positive direction. So I need to reach a point of zero gradient, or in simple terms, I need to reach the bottom of this curve, bell curve. So that is where the iteration will proceed. So this is called as gradient descent because with every iteration you want to keep decreasing your error. In simple terms, with every iteration the confidence limit of giraffe should go down and your elephant should go up for this given set of inputs. That means then that weights are stabilizing and you are reaching to a right conclusion. It is easier said than done, because if you happen to increment your error, say from x1 to x3, that means that you, in all probability, you will miss out the gradient. Or if you are going to do it in a very small intervals, then it will reach multiple iterations for you to reach the gradient. In deep learning terms, this is called as a learning rate. So how much you are going to increase your error rate or your weights so that you get a proportionate change in your error and until you reach your gradient. So that is called the challenge of gradient descent, and you are going to do it in multiple iteration. So rather than doing it in a static way, showing you a lot of neurons through a PPT, I thought we will make use of the free tool which is available from the Google APIs to do it. So I will give you the link of this particular tool in the description of this video. This is called as a playground.tensorflow.org, wherein TensorFlow has implemented CNN and it has opened it up for beginners and learners like us to interactively play around with it to get a hang of CNN. So here I'm going to have two input features x1 and x2 and one hidden layer, and this is output. And I'm going to keep my noise level at 10%. So basically noise is something which distracts you, which distorts the model, right? Now I'm going to, and epochs represent the number of iterations, or in simple terms, the number of records through which the model gets trained. So the loss factor now is pretty high. It's going to be around 50%. Now let us go ahead and run this model with 2 input features and 1 hidden layer with a 10% noise level, and let's see with after how many iterations where we get to a stabilized curve. Let's just play with it. It is training, and the output is slowly getting stabilized, as you may see here. And now it has reached a point, so at 0.035 I'm stopping it. So basically it has taken 438 iteration. So 438 iteration for you to get a loss factor of 0.035 with one hidden layer and 2 input features, right? Now let me go ahead and add one more feature, or probably 2 more features, and start playing it from the beginning with the same set of hidden layers, same set of noise. Now to reach the same 0.35, it has taken just 148 iteration. So with more the input features, the model will get trained more efficiently. That is one point we need to remember. Now let me keep adding hidden layers. Can I add 4 hidden layers? Yes. And these weights are visible to you, and in fact you can change the weight as well. So instead of this I can make it as 0.46, and any weights you can change. This is a highly interactive tool for you to play around and get a hang of CNN. Now with 4 hidden layers with the same level of noise, I'm going to again go through an iteration. To get to 0.35, it just took 92 iterations. So just compare in your first case scenario where I have 1 hidden layer and 2 input features. To get to a loss of 0.035, it took me 438 iterations. Whereas when I kept increasing my features, it accomplished it in a very less number of iterations. So there are 3 parameters is what I see here. One is more the input features, greater is your model accuracy, or you can increase the number of iterations. That is, you need to have a bigger and bigger data set available with you. Practically that is going to be a challenge. Or you can keep increasing your hidden layers. Keep increasing your hidden layers beyond a limit is not recommended solution, because then you are going to overfit your model. It is going to be trained in your data set to a level wherein if you are going to apply that model to a different data set with a different set of inputs but with the same distribution, it is going to error out. So overfitting is a common problem in deep learning algorithms. So to avoid it, I will say keep varying your input parameters. Try to give more and more features and try to have more and more epochs, that is your iterations, that is train it on more and more record sets. Increasing your hidden layer is not an optimal solution or optimal method beyond a particular threshold. So this is one way wherein you understand how your CNN works. So basically from all the way going back to an image, converting it into a set of vectors by applying your filters, by applying your normalization, by applying your pooling, and then keep changing your weights until you arrive at a definite path, so that for any given input it goes ahead and classifies the right output. And the objective of this 2 videos is to make you comfortable with the concept of CNN, so that when you implement it, remember you are not going to code all this, you are just going to take an implementation and apply a hyperparameter. You will be able to appreciate what this hyperparameter does to your algorithm. So that was the clear objective behind it. And before we wrap the session 2, let's also understand CNN has its own limitation. CNN, as you might have seen, it requires large amount of data and it requires intense computing. So that is definitely, I will say, a common disadvantages of any of the deep learning algorithms. But one of the limitations of CNN is it is applicable only to dataset which follows a spatial pattern. What I mean by spatial pattern is, say, take the map of US. Whether it is distorted, zoomed in, zoomed out, Texas cannot go ahead and sit in the place of an Alaska. Florida remains where it is. It cannot interchange with California. So it follows a structure. Similarly, if you take a face, you have eyes, you have a nose, you have ears, you have a mouth, all this in the definite place. The features may vary, the eyes may vary in size, the eyes may vary in shape, but eyes remain at the same place. So the whenever your data set is confined to a spatial pattern, CNN applies. If it doesn't confine to a spatial pattern, CNN cannot be used. Hope with session 2 you would have understood the working of CNN. In session 3 we will take an implementation, we will take a data set, apply to it and see how it works. So if you have any questions or feedback, please reach out to me at queryShammy@gmail.com. I will leave that email ID in the description section of this video, and also feel free to comment and share. Thank you. Thanks for your time. Thank you.